Good evening, everyone. Welcome to the extra problem solving session for the course Municipal Solid Waste Management. We have covered the content till week 12. We have covered all the weeks, and I think you have your final exam in October only. So, in this lecture, what we are going to do is we will go through a brief recap of what we have learned in all the lectures, and then we will try to solve few numericals based on these lectures. So let me first share my screen. So okay, let's start. Let me share the. So so let's start with week 1. So week 1 was about week one was about introduction to solid waste. What are the different classification of solid waste? What is municipal solid waste? What are the various components in the municipal solid waste? And what are the various parameters, physico-chemical and biological parameters of the municipal solid waste? So we will go briefly through what is solid waste. So solid waste is something that is useless or unwanted by the user. So a substance or a compound which is unwanted or useless by one particular user can be of use by the other user. So, it solid waste is overall it's heterogeneous because it consists of various components, and if it is coming from a household, it will be heterogeneous in composition. But suppose if it is coming from agriculture, like it is coming from a paddy field or it is coming from a rice field, then if it is coming from a paddy field, then it will consist the waste from the paddy harvesting. So it will be somewhat homogeneous. And if it is coming from rice field, then again it will consist of byproducts of rice harvesting, and that will be homogeneous in nature. So, some of the commonly used synonyms for solid waste are refuse, garbage, rubbish, scrap, or debris. So, debris is something which is bulky waste, such as the construction waste, and scrap, which has very high metal content, rubbish, which has very high ash content, and we know. Very high ash content, or in fact ash, these are of no use and they are sent at the last step of solid waste management, municipal solid waste management. At the last step, they are sent for disposal into the sanitary landfills. Next, we have garbage. Garbage, it consists of the biodegradable waste from the kitchen, which can be composted or digested. And refuse. So, this is more appropriate term for solid waste, as most waste can be utilized as a raw material for some other purpose. So here is the overall flow and waste generation chart. So suppose raw materials, so raw material processing of, like we have doing some mining of some metals and all, so waste will be generated. In the manufacturing process, waste will be generated. And then if suppose there is some product which is manufactured by a industry and it goes for further processing into another industry, then again in that secondary manufacturing, and there will be some waste generation, and from that the material goes to consumers. So from consumers, it can be processed and recovered, and it can be again sent to industries for manufacturing, or from consumers it can goes to disposal, and so on. So, so this is the waste generation for coffee, refining to coffee powder, coffee beans to coffee powder. So, why solid waste management? So basically, there is a very close relationship between the health of the public and the solid waste man and the waste management and proper disposal and collection. So the lying of the waste on the roads like this, or this can be saying that there are a lot of birds on sitting on these waste piles. So basically, these waste they generate lot of leachate and lot of landfill gas, and it attracts pathogens and rodents towards it. So these animals and microbes, they also carry lot of diseases which affects humans and as well as the animals and plants. So management of solid waste is very very important, because it will not only pollute air, it will pollute air, water, soil. So, and also it contributes to greenhouse gases. So methane and CO2 are emitted, so which are greenhouse gases, and they contribute to climate change. So proper management of solid waste management is very very important. So also one thing, during summer times, we all have heard about the news of catching of fire in the landfill. So this is because of degradation is taking place in the biodegradable matter of the solid waste dumped in the landfills. So because of biodegradation, and if anaerobic biodegradation is taking place, then methane is generated, and methane catches fire very easily. And in summertime, since the temperature is very high, so that's why they catches fire, and there is lot of fire cases of fires in the landfills in our country. So also, if there is not proper management of the solid waste, then this is the image of a turtle being trapped in the nets. So also, in earlier times, the practice was to dump all over the waste which is generated into a nearby sea or ocean. So if a city is lying near a ocean, so then all the waste was collected and dumped at a particular place from the shore. But these practices are not good, because these waste, they harm, first of all, they harm the aquatic ecosystem. And when there is high tide and events, then these waste are eventually taken back to the shores, and they keep kept lying on the shores. So this practice also is also not very good, and it has been stopped in very many countries. So solid waste, or in fact any waste, has lot of resources, and if these resources are recovered and taken from the solid waste, then other than being a nuisance, then these solid waste, they can act as a raw material for extraction of resources. Suppose if we take electronic waste, then in electronic waste there is lot of heavy metals which is being used. Not only heavy metals, there are other types of heavy metals which are also used, and some of them are very valuable. So in electronics, platinum is also used, silver, gold is also used, there is copper and other heavy metals. So if these metals are extracted from the electronic waste, then they can generate good revenue for that facility. So proper management and proper processing of the waste is very important. And if that is not possible, then, and if there is not that practice is if not followed, then rather than being a resource, that waste becomes a nuisance, for not just for the people but also for the municipality or a local authority which is managing that waste. Okay, so this is about management of solid waste in all old India. Okay. Let's go quickly to the first week, because first week is about the introduction. That's why we can discuss about the all the weeks in this only. So So the functional elements of the solid waste management. So these are the activities which are associated with the management of the waste from the point of generation to the final disposal. So suppose a waste is generated in a household, then it will be collected. So and again from primary collection, it can from all the households, it can be taken to a main street or some place from where it is loaded into the bigger vehicles, and from there it is sent to either a transfer station or some processing facility, or it is sent for disposal. So all these are the functional elements. Uh, so if we see waste generation, so it involves all the activities which leads to uh, generation of the materials which are of no use for the user, and they are thrown by the user. So in our country, with developing to a developed country, so whenever a country shifted from developing to develop, or from there is a tendency that there is shift in the income of the people, and with high income, what happens, there is a tendency to shift in there is a change in the overall composition of the solid waste which is generated. So suppose if in a developed country, all the people will have they will have sufficient money to purchase a packed food. So in a developing country or below that, there will be lot of wet components or biodegradable component into the in the solid municipal solid waste which is generated. So also in our country, since we are developing, so we have nearly 50 to 60% of the wet waste which is generated, but slowly this will shift from wet waste to a fraction. So slowly this will shift from wet waste to dry waste. Give me a minute. So after the waste generation, the waste are taken from the households or from the main dustbins to the to some processing facility or to a transfer station. So basically, there are two types of collection system. So first is a hall container system, and next is a stationary container system. So in hall container system, what happens that this entire dustbin or bin is loaded on the vehicle, and it is taken to the processing or disposal facility, and it is emptied, and then again it is taken back to the original position. So there are and in stationary container system, what happens, the container is fixed at a particular location. The vehicle comes, it empties the container into the vehicle, and and the container is kept back to its original position. So as I told you, there are two types of collection. So the collection from the sources or from the households is known as primary collection, and secondary collection, it involves the collection from the dustbin area to the landfill disposal sites, or to some processing sites. So next is the processing and transformation of solid waste. So it is very important functional element of solid waste management, but it is often ignored. So as I have told you that solid waste. So we are municipal solid waste consists of many components like wet waste or biodegradable waste. So this waste can be collected separately, and it can be sent for composting or anaerobic digestion. So in India, door to door, sorry. segregation of waste into dry and wet component is have started after the Swachh Bharat mission, in which the source is segregated, the waste is segregated at the source itself. So in door-to-door collection also, the wet waste is collected separately and the dry waste is collected separately. So the wet waste which has been collected separately, that can be composted, or that can be anaerobically digested. So from composting we can get compost, which can be used into agriculture fields, because these compost has very good organic carbon, and they have nutrients like nitrogen. So if you talk about the nutrients like nitrogen and phosphorus, so for nitrogen we have the Haber-Bosch process, in which the nitrogen is extracted from air and it is converted to ammonia, and then it is urea and other for nitrogen fertilizers are made and they are applied into the soil. But this process of converting gaseous nitrogen into ammonia is very costly and very energy intensive process. So a lot of energy is required for this conversion process, and uh, with increase in population, um, food security is very important thing to be thought of, because if there will not be sufficient supply of nutrients like nitrogen, phosphorus, and potassium into the soil for plants to grow, so then the growth will not be very good. Plant will be either stunted, or they will catch some disease, or and yield will not be good. So composting and extracting nutrients for some from some other waste is very crucial at this time for food security. So what happened in our country? I think my screen is shared only. So I am not speaking. So this is the screen. I think this is visible in my other screen. So I hope that others are also able to see the screen. So where I was, so in our country, um, a lot of fertilizers are imported from other countries. So if we close this loop from one-way flow of nitrogen and phosphorus from the raw materials to the consumers, and from consumers, like from not from consumer, it is applied into the soil and indirectly it is consumed by humans and animals. So from the consumers it gets lost into ocean, like then for fertilizers applied into the soil goes into the runoff, and it goes into the groundwater or surface water, and eventually it is lost into the ocean. And the back a flow of formation of phosphate rocks or from these from the ocean is a very slow process. So the rate at which we are exhausting the phosphate rocks is very high as compared to what it is being formed back from what is being getting lost into the oceans. So I was talking about nitrogen. Now next is the waste, like these biodegradable waste from the municipal solid waste. They consist of nitrogen, and they can be applied into the agriculture field if they do not have some contaminants into very large amount. So also it has been seen that when the organic fertilizers are applied into the soil as compared to the inorganic fertilizers, the quality, there is improvement into the quality of the soil, and also the yield is better as compared to the inorganic synthetic fertilizers. Also into the processing and transforming, another process for biodegradable waste is the anaerobic digestion, in which the organic matter is degraded by anaerobic microbes which grow in absence of air. They feed into these organic matter, and they produce methane and CO2 as a byproduct. So methane has very good, very high calorific value, and this methane can be used for cooking purposes, or it can be used to generate electricity, or it can be used into industries for energy generation and others. So anaerobic digestion of solid waste is also a very good option if you want to extract energy from the solid waste. And also after the anaerobic digestion, we will have some solid residue, and also we will have some liquid residue. Both of which will be rich in nutrients, and they can be applied into the agriculture fields. So next is transfer and transport. So this involves transfer of waste from the smaller collection vehicle to the larger transport equipment, and the subsequent transport of the waste to the disposal sites. So there are transfer station. So from the waste from all the smaller communities are taken and collected at a place, which is a transfer station. And in transfer station, the waste from the smaller vehicles are transferred into the bigger vehicles. So last is the disposal. So disposal of solid waste is the least is at the bottom priority for all the methods of managing of the solid waste in the integrated solid waste management. So in our country, the scene is like this, that earlier there used to be there was no separate collection of solid wet and dry waste, and these mixed waste are very difficult to manage, and eventually they used to end up into the landfills, and they used to attract a lot of animals, rodents, and pathogens. So solution for this types of dump sites where where there is waste dumped into the open and there is no cover given to the waste. That's why it has attracted a lot of these creatures. So the solution for this is the sanitary landfill or engineered landfill, where first of all the land is capped using some geomembrane so that landfill gases and leachate, they do not percolate into the soil and subsequently to the groundwater. And next is the waste is put into cells, and each cell is covered at the end of the day by using by using the nearby soil. So the waste is not open to the animals and pathogens. That's why they will not create nuisance, like they will not have a lot of birds and animals will not be attracted towards it. So let's move to the next level. So next is the types and sources of solid waste. So the solid waste can be categorized as into three: municipal solid waste, industrial waste, and hazardous waste. So the waste which comes from the household is the municipal solid waste. So this overall course was about municipal solid waste management. The waste from industries will be the industrial waste, and the waste like sanitary napkins or bandages or batteries. So these will come under the hazardous waste. So from households also there are hazardous waste which are generated, like sanitary napkins are there, diapers are there, blooded tissues and syringes are there. So all these hazardous waste, these are the provision is to collect these hazardous waste separately, and the collection for the hazardous waste overall solid waste is collected into wet waste is collected in green beans. Dry waste is collected into blue beans, and the hazardous waste are processed separately following the hazardous waste management rules. Like if it has biomedical waste, like it has syringes or blooded tissue, then these are first sterilized and then they are disposed of, and so on. So we can classify the municipal solid waste based on the sources, solid waste based on the sources. Like if it is coming from houses, then residential building, then it will be the residential waste. If it is coming from commercial activities, like if it is coming from hotel, hostels, then it will be the commercial waste. And if it is coming from institutes, and if it is coming from institutes, then it is the institutional waste. So next is sampling and characterization of the municipal solid waste. So they are sampled by following the quartering method. So suppose 100 kg of the waste is taken, so it is divided into four fractions of each of 25 kg, and that 25 kg is again divided into four fractions, and again that is divided into four fractions. So and finally the waste is taken and it is sorry, so out of these four, any two will be taken and it will be further divided into four fractions, and again any two will be taken and it will be again divided into four fractions, and nearly 10 to 12 kg of the sample will be taken, and for chemical analysis it will be dried, grinded and sieved, and the other physical analysis will be done directly. And sampling should be done for all the four seasons, 7 days a week, and at least twice in a season. So, since solid waste, municipal solid waste has a very heterogeneous composition, that's why before chemical analysis we need to. So that's why this quartering method is done to homogenize the waste, and then it is further reduced into particle size for the chemical analysis. So, in the physical characteristics. So in the physical characteristics, specific weight or density is determined, then particle size analysis is done. So these are the trommels which are used to sieve the waste into different particle sizes. And next is the field capacity. So how much moisture, so this is the field capacity of solid waste is the total amount of moisture that can be retained in the waste sample subject to the downward pull of gravity. So next is the chemical parameters. So the first one is the proximate analysis. So in proximate, so the proximate analysis consists of determining the moisture content and volatile matter content and ash content. So moisture content can be determined by taking samples and putting and placing in at 104 degrees centigrade for 24 hours. Ash is determined by combusting at 550 and ignite the waste between 700 to 950. Samples should be covered so that the sample is not in contact with air, otherwise complete combustion of the waste will take place, and ash will be found instead. So in volatile matters, the volatile organic compound escapes out, but if there will be air, then complete combustion will take place and ash will be found. And if you subtract moisture content, volatile matter, and ash content from 100%, then whatever value will become, it will be the fixed carbon. And fixed carbon is the carbon which does not degrade easily, so they remain for a very long period of time. And so And if some waste has very high amount of fixed carbon, then it shows that that waste will they will not degrade in a shorter time, and they will remain for a very long time. And so this method is used in pyrolysis, where some waste is is pyrolyzed, and in that process, what happens, the fixed carbon content of the waste increases. So if the fixed carbon content is increasing, so that waste will not degrade in shorter time, CO2 will not be released, and so in this way, we can reduce the amount of CO2 which will go into the atmosphere, and it will not contribute to the climate change. So this is one such approach to convert the easily degradable carbon into the fixed carbon, so that overall contribution of CO2 will reduce into the atmosphere, and it will slow the rate of climate change. So these are the data for uh, moisture and volatile matter content and various fixed carbon and calorific value for waste from different income groups from the city of uh, from Jalandhar, one of the city in Punjab. Let's move to the next. So next chemical analysis is the ultimate analysis in which carbon, hydrogen, nitrogen, oxygen and sulfur is determined. And carbon to nitrogen ratio is important for the biological conversion process. So some optimum value of carbon to nitrogen ratio should be there into the should be there into the raw material if it is getting going for composting and anaerobic digestion. And also after composting and anaerobic digestion, some optimum amount optimum value of carbon to nitrogen ratio should be into the end product before it is applied into the agriculture field. So next is the energy content or the calorific value. So this is determined into bomb calorimeter. So some sample is taken and it is ignited in this instrument and uh, it is calculated using this formula. So So next is the metal contains. So to determine the metal contains in solid waste. So first they are digested using nitric acid or some other acid, and after digestion, all the metals come into the extractant solution, and that extractant solution can be analyzed into instruments like AAS, that is atomic absorption spectroscopy, or ICP-MS, ICOES, and others. So next characterization is the biological characterization. In so the first is the volatile solid. So volatile solid is often measured as a used as a measure of biodegradability of the organic fraction of solid waste. So volatile solid is not the correct indicator of biodegradability. So some compounds can be highly volatile, but it can be low in biodegradability. Like newspaper, they have highly volatile, but they have low biodegradability because they have lesser uh, degradable carbon or organic carbon fraction is very less in newspaper. That's why they have lower biodegradability. So there are two components: biodegradable and non-biodegradable. So if it has biodegradable organic matter, then only it have very high biodegradability. But if it has high volatility, then it doesn't mean that it will have very high biodegradability. So the biodegradable fraction of the municipal solid waste, so they can be a nuisance because what happens when organic waste is like the waste from the kitchen is stored, so they start to get degraded after 24 hours. So proper collection and management of the wet waste or the biodegradable fraction of municipal solid waste is very important. Otherwise, it will attract flies, it will create a very bad smell. There will be a lot of odor in that area. So next is the factors affecting a affecting solid waste generation rate. So there can be waste collected can be done by two types, like commingled waste and the source separated waste. So after Swachh Bharat mission, source separation has been started in India, where the wet waste and dry waste is collected separately by the user itself, and it is being collected separately by the municipality. So these are the variation in generation and collection rates for different cities. So the very first factor affecting the waste generation rate is the effect of source reduction on waste generation. So the topmost priority should be reduction in the waste which is being generated. So if lesser is being generated, then lesser waste will be sent for further processing, and it will and lesser waste will be sent for disposal into the landfill. So the first approach should be that there is reduction into generation of waste. So approach should be like use of uh, uh, steel plates instead of disposable plates. The approach should be like the material which we are purchasing, they do not have very lot of excessive packaging. So reusable materials and substance should be used, so that will reduce the amount of waste which is being generated. So these recycling status in US is given as, so we can see here that nearly 66% of the paper and paper board is being recycled in 2017 US, and it has increased slowly from 1960 to 2070. So with more and more awareness among the people, and more efficient collection and segregation, so this recycling of the various materials have increased. So next is public attitude. So legislations have been imposed to ban the use of the single-use plastic. So this will no, no, decrease the amount of the colored plastic, single-use plastic which are being generated. So next is the legal laws and legislation. So there can be ban on some of the materials which is being used. Next is encouraging the purchase and reuse of the recycled materials. So next is the effect of geographic and physical factors on waste generation. So in hilly areas, the waste generation is less as compared to the to plain areas, and production is higher during warmer weather than the colder weather. So so we then after first week, the second week was about primary collection, and then the third week about secondary collection of the solid waste. And then we have seen lectures on transfer station. So, transfer station can be of three types, where the waste is directly transferred from smaller vehicle to larger vehicle, or there can be storage also, where the waste is first stored into the transfer station, and then from that it is loaded into the bigger vehicles, or it can be combined type, like it have both the provisions for transferring the waste from smaller vehicles to bigger one, or there can be storage also if there is uh, depending upon the season, or if there is not availability of the bigger vehicles. So after transfer station, I think there was lectures about processing of the waste. So in the processing, we have seen some physical processing, like how the plastic waste and cardboards are separated, then they are shredded, and they are like plastic. It is separated into different components, like plastic bags will be separated, then other plastic materials will be separated, and then it is further sent for further steps like particle size reduction or compaction, and then they are made into bales, very big bales, and then they are sent to the industries where they require that as raw materials. So after that, we have seen chemical processing. So in chemical processing, there can be thermochemical processing, like uh, incineration process, where the whole waste is combusted into excess air, and the waste is converted into ash, but lot of heat is generated, and that heat is used to run the turbine, to generate steam into the boilers and run the turbines and generate electricity. or the waste can be pyrolyzed in absence of air to produce syngas, which has methane, hydrogen, CO2, and other gases. So this has very high calorific value, and they can again be used to generate electricity, or can be sent to industries where there is a where the where methane is required, or where they can use to generate heat and all. So, and the other process is gasification. So, in gasification, some combustion is done into limited supply of air. So, whatever stoichiometric requirement of air is required to combust that material, so lesser amount of air or oxygen is supplied. So, the end product here we get is three fractions syngas. So, syngas can be used to for energy generation and others. So we have bio oil. So uh, whatever the gases product is coming out from gasification and pyrolysis, they can be condensed to get the bio oil, and the other and the whatever is remaining into the gaseous phase, that will be the syngas, and the solid residue will be the char. So depending upon the initial composition of the waste, so these char can be enriched with nutrients, and they can be supplied into the into the agriculture fields. So after thermochemical processing, we have also seen the chemical processing, like how metals and glasses are melted and extracted. And next, we have seen the biological processing, in which um, we have seen, I think, two processes. First was the composting, and next was anaerobic digestion. And also, we have seen vermicomposting, in which special type of earthworms are used to. So these earthworms eat the waste, and their excreta is the organic matter which we get, which is very rich in organic carbon and nitrogen. And then we have seen lectures on landfills. So landfills are the sanitary landfills are the engineer landfills. So where there is proper compaction and dumping of the waste into cells, and these cells are covered with soil layers. So we have seen different type of landfills, and then we have moved to the management of landfill gas which is being generated, and the leachate, that is the liquid product which comes out from these landfill. They have very high COD, they have very high BOD, they have very high pollutant content, like they have very high heavy metals, and other compounds. So proper treatment of these leachate should be there. So there is provision for proper collection of these leachate which is being generated, and there can be a treatment plant at the site itself, water treatment plant at the site itself, or these leachate will be collected and sent to the uh, to other treatment plants. And also the landfill gas. So since methane is produced, so after a landfill has been capped, if it has fully been covered and capped, so into the initial years after closing of the landfill, since there will be air which has entrapped into the spaces between the waste, so initial years will the waste will degrade as aerobic, and the bottom layers, and also with time these air will be exhausted, it will be completely used, and slowly that degradation will shift from aerobic to anaerobic, and during anaerobic degradation methane will be produced, and methane has higher potential for climate change in shorter term as compared to CO2. That's why tapping of this gas is very important, and also as I have discussed that methane has very high calorific value, so this can be collected and used for further purposes. So after that, uh, there was lectures about various rules. Like there was lecture about um, biomedical waste. There was a construction and demolition waste management rules, and then we have seen biomedical waste. Then we have seen the street sweepings, like how street sweepings are managed. Like it is divided into various fraction. So if it has a biodegradable matter, then it is sent for composting, and if it has inert matter, then it is sent to the landfills. And also the cleaning of the drains, that also comes into the street sweeping. So the silt from the drains, they are directly sent to the landfill, because they have very high contaminant concentration, so they are not reused. And next we have seen the hazardous waste management also, and then There was lecture about integrated solid waste management and also about the municipal solid waste management 2016. And then we have seen last week lecture was about financing, like how the overall project for the municipal solid waste are made and how financing and other things are done. And so I think the last lecture, just give me a minute. Okay, so there was lecture about finance and public-private partnerships also. So, involvement of private partners have uh, uh, resulted in very good. We have also seen case studies where the involvement of public-private partners have converted some of the landfills from the open dumping site to some very closed and successful capping of the landfill, and they are converted into green belts also. So, um, also we have seen some case studies where the involvement of PPEs and into managing of the solid waste has failed due to various reasons and all. And we have seen we have few case studies based on these. And so this was all for the overall content which we have seen in this municipal solid waste management course. So now we will try to solve a few numericals. I think there was one numerical which was left in week 10. So first we'll try to solve that numerical, and then we will try to solve a few more, and then that will be all for today's class. So let me share my other screen. So the question is, determine the ratio of waste to cover material volume basis as a function of the initial compacted space specific weight for a solid waste stream of 70 tons per day to be placed in 3-meter lift with a cell width of 5 meter. Slope of the working phase is 3:1. Assume that the waste is compacted initially to an average specific weight of 350, 480, and 600 kg per meter cube. The daily cover thickness is 15 centimeter. So we will solve this question in parts. So first we will determine the daily volume of the deposited solid waste. So I will give you all 3 minutes to solve this, and then we will try to see how to solve this question. So please use this formula. Like we know that specific weight is the ratio of mass to the volume. So we have to find out the how much daily volume of the deposited solid waste is being. So how much volume of solid waste is deposited daily? So we have been given the waste stream load which is coming daily to the that landfill, and we have been given the specific weight for the waste. So we can use that to find out how much volume which is being generated daily. So please use this formula and try to find out. So let's try to solve the question. So I got one value as 95. So we have to find for each compacted specific weight how much volume will be generated. So okay, let's first find for 350 kg per meter cube of the. So the volume of waste to be handled or placed into the landfill will be the mass which is being generated is 70 tons. So since specific weight is in kg, so we will convert it into kg. So we'll multiply by 1000 and then we will divide by the specific weight, which is 350 kg per meter cube. So it will be 200 kg. So we will find the volume of waste to be handled for on the basis of per day, sorry. So it will be 200 meter cubes. So if the specific weight is X is given as 480 kg per meter cube. So then the volume of the waste to be placed into the landfill to be deposited, it will be 70 into 1000 upon 480. So it's coming out to be 145.8 meter cube. So next one is the specific weight is 600 kg per meter cube. So volume of waste will be 70 into 1000 upon 600. So it's coming out to be 116.7 meter cube. So we have been given three specific weights. So we will find out the volume of waste which will be which need to be deposited based on all the three specific weight. And then, so let's see next part. So we have to find out the length of each daily cell. So we can find out the length. So we can divide the volume by height and width to get the length of the cell. And we have seen that we have to place into 3 meter lift. The height is given as 3 meter and the cell width is 5 meters. So we can divide by 3 into 5 to get the length of each daily cell. So please find for each of the three cases and write the value which you are getting, and then we'll see how to solve this. Find the length for each cell. So first for the 350, specific weight of 350 kg per meter cube. So the length of cell will be, volume we have find out as 200. So 200 meter cube. Height is given as 3 meters and width is 5 meters. So it's coming out to be 13.3 meter. Next for specific weight of 480 kg per meter cube. Meter. So for each specific weight which is being given, the length of cell will be found out by dividing with the height and width of the cell of each cell, which is already being given in the question. So for 350 kg meter cubes, so the volume of waste generated per day will be 200 meter cubes, and the length of the cell will be 13.3 meters, and for 450 sorry, for 480 kg per meter cube specific weight, the volume was coming out to be 145.8. And when we will divide with height and width, we are getting 9.7 as the cell length. And for 600 kg meter cube specific weight, we were getting the volume of 116.7 meter cube. And when we will divide it by height of 3 meter and width of 5 meters, we are getting the length of the cell as 7.8 meter. So let's move to the next part. So we have to find out the cell surface areas. So for each specific weight, again we will find out how much we are getting the cell surface area. So again, please try to solve and then we will see how to solve this. Okay, let's find the cell surface area for each. So this is the cell. So this is the length of the cell. So the vertical one is the height, and in the line going inside the screen is the width, which is 5 meter given, and the height is given as 3 meter. So for top, this section for top of the cell, so the surface area will be width into length. So at 350 kg per meter cube of the specific weight, so the top surface area will be length is 13.3 into the width, which is 5. So we are getting 66.5 meter square. So at 480 kg per meter cube of the specific weight, so the length was 9.7 and width is 5 meter. So it is 48.5 meters square. And at 600, it is the length was 7.8 and width is 5. So it's 39 meters square. So next we will find out the front face. So this we will find out for the face of the cell. So the face is made from height and length of the cell. So area for the face at 350 will be we have length as 13.3, height is 3, So for the three specific weights, so the surface areas will be in 12, 126.2, 92, and 74 meters square for the three different specific weight. So now let's find for the side of the cell. So the surface area for side for each of the cell will be same because the width and height is same for all the cells. So it is coming out to be 47.4 meters square. So now let's move to the next part. So we have to find out the volume of soil for daily cover. I think daily cover. So the daily cover thickness is given as 15 centimeter. So find the volume of the soil for daily cover for all the three specific weight which is given. So please try to solve this and then let's see how to solve this. So the volume of soil for daily cover will be, it will be thickness of daily cover multiplied by into top surface area plus side surface area plus front surface area. So for 350 meter cube per kg of specific weight, so we have thickness as 0.15 meter into the surface area for top cell was 66.5, for side was 147.4 and front was 126.2. So it's coming out to be 36 meter cube. For 480 kg per meter cube of specific weight, so it will be 1.15. Top cell area was 48.5. Side was 47.4, same for all. And the front was 92. Coming out to be 28.2 meter cube. And for 600 kg per meter cube of the compacted density, it's coming out to be so it's coming out to be 24.1 meter cube. So we have find the volume of soil for daily cover for all the three specific weights. So we are getting uh, least volume of soil for 600 kg per meter cube of the specific weight, because if the waste will be will be compacted more, it will take lesser volume, and so lesser volume of soil will be required for covering it. Now we have to find out, so this is the last part, we have to find out the ratio of waste to soil cover. So again, we will find out for all the three cases. Please try to find this and then we will try to solve this. Let's find the ratio of waste to cover soil. So for 350 kg per meter cube of the specific weight, so ratio of waste to cover soil. So, so we have find out the volume of waste generated as 200 meter cube, and the volume of cover soil was 36 meter cube. So we are getting the ratio as 5.5 is to 1. So for 450 kg per meter cube, so the volume of waste generated was 145.8 meter cube divided by the volume of soil was 28.2. Five 5.17 is to 1. And for 600 kg per meter cube, so the volume of waste is 116.7 meter cube. 116.7 divided by volume of cover soil is 24.1. Coming out to be 4.84 is to 1. So we have find out the waste ratio of solid waste to the cover soil. So we can see in this question, like as the specific weight, as the solid waste is more and more compacted, like we have compacted the waste to 600 kg per meter cube. Here the overall amount of waste to be placed into the landfill has decreased, and also the amount of cover soil to cover that cell has also decreased. So as the volume, as the waste will be more and more compacted, so lesser space will be taken into in the landfill, and lesser amount of soil will be required to cover the soil. So this was the question which was left for from week 10. So this is the last question. So I hope all the week materials are clear to you all. And I hope this question was also clear. And if you have any doubt, then you can ask, or otherwise, we can end the session here. And also, all the best for your exam, which is going to be in October only. I think there is no question. So thank you so much for joining. You can leave the meeting here. Okay, thank you. All the very best. So Okay, thank you so much for joining. I'm ending the session here. So thank you. Have a nice day.